Hello everyone, we'll be covering distance and displacement today. By definition, distance is defined as the actual length of the path covered by an object. Since it really doesn't depend on the direction, so it is a scalar quantity. On the other hand, displacement is known as the shortest straight line path between initial and final position of the object. Now, since it is pointing from initial to final position, so obviously it is a vector quantity. Let us take one or two examples, illustrations of the same to be more clear about the concept of distance and displacement. The first one is if supposing I'm walking on a path where the two are making an angle of 90 degree with each other. So I'm going from A to B and then from B to C. Let this distance be 3 meters and let this distance be 4 meters, which means AB is 3 meters and BC is 4 meters. So to move, an object goes from A to B and then B to C. So the distance that the object covers is AB plus BC, which is equal to 7 meters. But the displacement is, as we just understood, between initial and final position. This is my initial position and this is the final position. So it is AC. Now AC, if you see, is the hypotenuse of the right triangle. So we have to use the rules of geometry to find out its length. So that will be under root of 3 square plus 4 square, which is equal to 5 meter. So displacement is slightly less than distance. Another illustration, if we take the second one, is that of a straight line path. So supposing I'm going on this straight line path from A to B and let the length of this path AB be equal to 20 meters. From A to B and then I come back to say C. Let this be 5 meters. So if an object is going from A to B to C, then the distance covered will be AB plus BC, which is 20 plus 5, 25 meters. But displacement will be AC, which is 20 minus 5, that is 15 meters. So one has to be a little careful in finding the displacement. Now these two questions are there from NCERT. So this is from chapter 1. This is the in-text question where the farmer one and the other one is the question from the exercise. So just discuss these to have more clarity on the calculation of distance and displacement. So in the first question, a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes and 20 seconds from its initial position? Now, if you see, the field is square shaped. So it's like this. So let this be A, B, C and D. If the farmer is moving along the side in 40 seconds and one side is 10 meter and it's a square, so all the sides will give me the perimeter as 40 meters. So he goes around once along the boundary of the field in 40 seconds. So in 40 seconds, he covers 40 meters. So in 1 second, he will cover 1 meter. That's one way of looking at it. Now let's see the total time. Total time that he is using is 2 minutes and 20 seconds. Convert the whole into seconds. It will be 2 into 60 plus 20, which is equal to 140 seconds. You need to find out the displacement. So if he goes around the boundary of the field in 40 seconds once, so he will be going from A to B, then C. So 40 seconds over. Again, second time. Again 40 seconds over. 80. Third time. 120. After that, he is moving further on for 20 seconds only. So which means he'll be going from A to B and B to C. So his final position is C now. So at the end of 140 seconds, the farmer reaches C from A. So his displacement is equal to AC, which again you can find out using Pythagoras theorem. So AC is equal to under root of AB square plus BC square, which is 100 plus 100 under the root 200 or 10 root 2 meters. That will be the displacement. So distance and displacement questions are not tough as long as you are able to apply the concept correctly. Similarly, there's another question in the exercise where it says that an athlete completes one round of a circular track of diameter 200 meter in 40 seconds. What will be the distance covered and displacement at the end of 2 minutes and 20 seconds? So method is the same. Here instead of the square boundary, you have a circle. The diameter is given 200 meters. So athlete, let's say, starts from A, goes like this, reaches B and again goes back to A. So again the total time that the athlete has is 2 minutes plus 20 seconds. As we calculated in the previous question, it will be 140 seconds. Fine. So now for one round, he takes 40 seconds. So for one round, the circumference will be 2 pi r or pi into d. So pi into 200. Let's not change pi. Let it be as it is. So he covers 200 pi meter in 40 seconds. So in 140 seconds, distance covered will be 200 pi divided by 40 into 140. So I am doing it like this just to make it a little easy for you to understand. This becomes 700 pi. If you wish, you can convert it now by multiplying pi, changing pi to 22 by 7, and the answer is 2200 meters. That will be the distance. For displacement, he starts from A, comes back to A, 40 seconds, 80 seconds, third time, 120 seconds. So after 20 seconds, he'll be reaching B, which means exactly opposite to A. So displacement will be, which is defined as the shortest straight line path. So it will be simply AB, the diameter. So in this case, displacement is equal to AB, which is the diameter of the circular path. So this displacement is 200 meters. With these two questions, there's a lot of clarity which appears to apply the concept of distance and displacement. Most of the times, you'll be getting similar questions. The time could be different, the diameter or the side length could be different, but method remains the same. So, happy learning. Thank you.